Hi friends, let's have a look at problem 1401, circle and rectangle overlapping. In this video, we're going to explain a solution by locating the nearest point in the rectangle to the center of the circle. So this will enable us to give solutions to this problem. So in this problem, the problem statement is very simple. We have a circle and we have a rectangle. So we want to check if they have overlap. So here are three examples. In the first example and the third example, the returns are true, and in the second one, it's false. So here are some constraints. So notice that the radius is strictly positive. It's bounded below by 1, right? So also we know that x1 is less than x2, and y1 is less than y2. In other words, x1, y1 is a lower left corner of the rectangle, and x2, y2 represents the upper right corner of the rectangle. So with that said, we are ready to do the coding and analysis. So this problem actually is a Google interview question. So this logic actually is simple if we can quickly digest the mathematics. Otherwise, it might be challenging. So here our strategy will be very simple. So we want to find the nearest point in the rectangle to the center of the circle. So basically we want to check this distance. So this is actually very well known. So for this problem, here we are working in 2 dimensions. So actually in the generic n-dimensional case, so the method will still work. Here I want to find the point which is nearest to the center. So I'll define a capital X and capital Y to be none at the very beginning. So we want to assign the values. So for this problem, we need to check each dimension. So here we have 2 dimensions. We have X dimension, we have Y dimension. So basically, we want to check the closed interval corresponding to each dimension in the rectangle, and then we compare with the corresponding coordinates for the center of the circle. So if the corresponding coordinates lies in the closed interval corresponding to the rectangle, so the corresponding coordinate will be set to be the center coordinates component. Otherwise, we either choose the 2 ends depending on what's the relative location of the center coordinate with respect to the closed interval. So here, let's examine the X dimension. So for X dimension, we know that the rectangle runs in this closed interval from x1 to x2, right? So basically, if the X center is in this bound less than or equal to x2, so in this case, we are going to set I to be the X center, right? So otherwise, so if X center is less than x1, so then we want to set capital X to be x1. Other case, we're going to set to be x2. So we can do the same thing for the second dimension. So it's y1 and y2, right? So if y1 less than or equal to y center and less than or equal to y2, in this case, we are going to set capital Y to be the y center. And otherwise, if y center is very small, say less than y1, so we're going to set y to be y1. And otherwise, so the y center will be greater than y2. In this case, we are going to set y to be y2. So in this case, up to now, so we actually determined the xy point, which we want to compare with the radius. So basically, what we want to return is we want to compare the distance of this point xy with respect to the radius, right? So let's consider this to X center, right? So here I can consider the Euclidean distance square, right? So y minus y center, so raised to the power 2, and then we compare if it's less than or equal to the radius square. So notice that we include equality. So in this case, they touch, right? So this will be a solution to this problem. So the logic actually is very simple. if you digest the mathematics. So now let's first do a test. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the generic cases. So this is the one solution. So overall, basically, we want to check each dimension, right? For each dimension, the rectangle project to a closed interval, and then we want to consider the corresponding coordinates for this component for this with respect to this closed interval. So if x center lies in, for example, this interval, then we are going to set the corresponding coordinate to be this value. If it's too small, we are going to set it to be the one end, say x1. If it's too large, another end. So it actually works for all dimensions. So once you set down this point, and then you just need to check if the distance of this point with respect to the center is less than or equal to the radius. If so, they have overlaps. Otherwise, not. So this is the one solution. So this solution is very analytic. So next, I want to explain a geometrical one. So the reason we want to explain the geometrical one is due to the fact that this geometrical one help us to digest or help you digest the problem. So here you can look at this one. So you have a rectangle. So here C is the coordinates for the center of this rectangle. So from the center to the say top right corner, there is a vector corresponding to h, right? So the center of the circle is P and the radius length is R, right? So we can compute, or we can see, we can move the coordinates. We can establish a coordinate center or origin using this the center for the rectangle. So this corresponds to use the coordinate of P minus the coordinate of C, right? So then you are in this scenario. So, but this CP vector can be in each of the quadrants. But you know, if we take absolute value, it corresponds to map it to the first quadrant. Basically, this is a good reduction of the problem. So once we have this, also we know the h, right? And then we use this v. V is the vector corresponding to C and P, right? Starting from C and ending at P. And then by triangle rule, right? So this from this corner to this P, the right one is nothing but V minus H as a vector. So this vector, right one, basically can measure the distance of the circle with respect to the rectangle, right? So if this length here actually is the distance from the to the circle, and then for this one, basically in this case, the red vectors, in other words, so V minus H, actually the x coordinate will be negative and the y coordinate be positive. So this, if we set the x coordinates to be 0, then this rectangle one corresponds to the nearest distance. Similarly, you can look at this case. This case corresponds to the fact that the y component of V minus H is negative. Then this one, the x distance, will be the nearest distance. So this case is both x and y coordinates of V minus H is negative. In this case, I actually set u equals 0, 0. So in other words, this is in this one. So this part, actually, this solution is the same as the solution we provided, but it's more geometric. Still, we want to find the nearest distance of the center with respect to this rectangle. So this one actually corresponds to compute the cosine or dot product with respect to this line. So you can regard this line as a vector, right? So it's 1, 0 or negative 1, 0, but you know, distance is the same. So this one corresponds to compute the projection to the to x coordinates, right? So corresponding to, again, dot product. So if you have some background in mathematics, you can write in a component in a vector format. But for our purpose, we can do it very easily. So first, I can get the we can get the x center, the y center. So this is very easy to compute, right? So this is x1 plus x2 over 2, and this is the 1, and then y1 plus y2 over 2. So this way we get the C in the graph, right? So vector C. So now we already know the p vector is actually the p vector is x center, y center, right? So now let's compute the rectangle center to circle center. So this is nothing but the HP vector. So here I'm going to use x center minus this rectangular center, right? So y center minus rectangular y. But I want to map this to the first quadrant, so we're going to take absolute value. So with this done, so we have the necessary information. Now we use this vector minus the h. So how can we compute h? So basically, this is how rectangle. See, I will write some suggestive name. Half diagonal. See, vector. Let's see. Half diagonal means that this vector will have a length of half the diagonal length. So here is x2 minus rectangular x. Y2 minus y2 minus rectangular y, right? So now we have this two vector, so we can compute a big vector, that is it. So this is nothing but h vector, you can think. So this is the HP vector, and also you can call it vector h. And this is the vector. Oh no, this is the v. This is the h, right, in that graph. And then x basically is v minus h. So we can do something like this. I can use the list comprehension, right? So I can take max. So a minus b, or 0, right? For a, b. Notice the order is important. Zip. I want to use this one. Rectangle center to this one. Minus this one. So basically, this vector length will give us the nearest distance from the center of the circle to the rectangle. So if this one is less than the radius, then we are going to have overlap, otherwise not. So here we just need to return x naught square plus y naught right square. So let's see if it's that then radians square. So this is actually a more geometric solution. So this one is more analytic, right? So now let's test it first. Y is not defined. Let's see. So x naught x1. So let's run it. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So let me make some remark. So this solution is more analytical, right? So for this one, it's more geometric, right? But these two solutions are actually the same idea, based on the same idea. So you can also write so in vector format. So notice that here we have 2 dimensions, right? So in general, if you have n dimensions, you can do the same thing, right? But you can use vectorization. So similarly here, you can use a for loop to do all the things and then do comparison. So with that said, I guess we finished this video. Thank you.